Contemporary Stone Architecture, the Art and Science of Building in Stone. So the new Stone Age exhibition at the Building Centre, which has now finished, celebrated the sustainability, practicality and inherent beauty of stone. In the light of the climate crisis, the materials that make up our built environment need more than ever to prove their worth. And stone has serious sustainability credentials, with the ability to reduce a project's embodied carbon by an incredible 90% compared to typical steel or concrete frames. And we'll be learning a lot more about that this evening. So we're joined by our three curators of the new Stone Age show, Amin Taha of Groupwork, Steve Webb of Webb Yates, and Pierre Piedo from the Stonemasonry Company Limited. The first half is going to be a roundtable discussion. So we'll be joined by two of our curators and our two special guests, as well as the sponsor, Polycor. Then there'll be a short break in which you'll have time to make a cup of tea, to briefly talk to the kids, to walk the dog, to put the dinner on, but come back at 7 o'clock because the second half will be an interview between Amin Taha and Gilles Perraudin. And there'll be the option to hear that conversation in French or in English. And I'm going to talk you through it when we get to that point. But on Zoom, you have the ability to click whether you want to hear in English or French. There's questions and answers on Zoom. So instead of waving your hand at the end of the event, you'll be able to ask questions as you go along. So we can moderate those, but feel free to ask whatever comes to your mind. So I want to thank all the speakers this evening, and I'm going to introduce them one by one. We were very moved actually by the amount of press coverage and the number of visitors we had to the Building Centre before, sadly, the pandemic interrupted our public programme and life as we know it. So we're very happy to be able to bring everybody here together this evening to celebrate stone and to talk to not only our three curators, but also to contemporary practices that we are happy to share. We were happy to share them in the exhibition. We're very happy to introduce them again this evening. So this evening, without further ado, I'm going to hand over to Valerie Bergeron, who's Director of Business Development at Polycor. And if you haven't seen it yet, watch the brilliant film with Valerie speaking about the beauty of stone and the art of quarrying. It's on the Building Centre website, so check that out later. But Valerie, good evening in Paris. We'd love to hear from you, to hear more about stone and about your work at Polycor. And thanks again for sponsoring the show.
Well, thank you, Vanessa, for the time. Just allow me to talk to the French speaker audience before I start. Pour nos participants en français, la deuxième partie de l'événement, la conversation à l'heure de Paris, nous aurons la traduction simultanée pour tous. So as Vanessa said, my name is Valerie. I work for Polycor. Just a little note on Polycor to start with. For people who don't know us, we're the largest quarry owner in the world. We have over 50 quarries in North America and Europe. And we have teams and projects around the world. We got involved with the new Stone Age in the Building Centre. We started our journey about 2 years ago when we met Pierre Piedo and Steve Webb, and they told us about their genius idea, very groundbreaking idea about building with stone, which is so weird because it's such a new idea because it's not been done so much in the last 70 years, especially for a North American like myself. I mean, nothing is done like that in North America at the moment, but it's been done like that for over thousands of years in the past. So we got excited, we got interested. They told us about the problem that the stone industry, the actual stone industry had for building with load-bearing stone, because as you know, stone is now being relegated as a finishing product. So obviously as quarry owner, we tend to plan our extraction for the end product, for a finishing product. So we are starting to think of ways to accommodate this new Stone Age, this building with load-bearing stone. And for the architects, what Polycor, what we want to offer now is three different things. We want to help with the know-how. We think there's this thing that's missing, some kind of guidelines, some kind of handbook to help architects being able to design in structural stone. The other thing that we want to address is to offer a reliable product. Not that our product is not reliable at the moment, but something that is tested, that is graded, that's a little bit like the wood industry has done. And that's something that we are committed to look into and to bring to the table. And the third thing is really with the norms. The construction code right now is not made to build with structural stone. I'm not sure the cathedral would be allowed to be built right now with the code we have, which is insane because they've been to the biggest test time. So we want to help with the lobbying and help in that way. So in this day and age, where finding new ways to reduce our carbon footprint is not only necessary but vital, stone just makes much sense. It's green, it's available in huge quantities, it has a life cycle like no other material, and it can be reused an infinite numbers of time. If there's only one thing, there's going to be so many inspirational speakers tonight, but if there's one thing I dream you all get, is that you get inspired and you join the movement. If you go to the office on your bicycle, you recycle, you're vegan, eating only locally ground veggies, and then you come to the office and you design a steel and concrete building, for me, it just doesn't add up. Next time you design, just ask yourself, is there a more sustainable way to design that? Is there any way stone can work in my design?
So one place that stone did work brilliantly was 15 Clerkenwell Close, and that was the starting point for the exhibition. Yeah, so thank you, Valerie, for that call to arms, call to action from architects specifying materials and the importance of stone. We don't need to tell our next speaker, Pierre Piedo, about the importance of stone, because he is the poster boy for structural stone. So Pierre, I'll hand over to you and say thank you for joining us this evening and tell us about stone.
Okay, well, I hope everyone can hear me. Yes, thank you very much, Vanessa, for the introduction. Poster boy, I don't know, but it was a great pleasure that the Building Center really got hold of us and to talk about stone, and with all the curators to be able to share our love of stone and our love of building. So I'm going to try to share a content. So be ready. Here we are. Hopla. Okay, you see a beautiful white page. It's where dreams come true. But here we are. We've got, I think everything is, I hope everything can see my screen. So for a very long time, of course, stone has been a sort of, shall we say, material compass of the material world, the construction material world. You know, you could not go around Mediterranean without seeing one of these incredible buildings. But if you were going to do just 100 years as train was taking over, you need some beautiful bridges to go over rivers and so on. And until 1900, stone was still very much used in a structural matter. And all over France until, as I said, the 1900, you could have seen this incredible stone structure bridging rivers and so on. So there is a bit of outdated view about what is a stonemason, what is stonemasonry. Usually people have cathedral in their heads, have people just working stone in a sort of much more artisanal way. And they've got this twisted view of maybe an industry who never caught up with the modern time. However, this industry has been always thriving, has been always very much industrialized. Here you can see two pictures of the beginning of 1920s 1910. And you can see or imagine the numbers of stonemason working with a new steam engine, working this huge quarries, open air quarries or underground quarries. And it was not a small industry. It was really, really a very big and thriving sector. So as you can see here, intricate decorative ornaments were just churning out from all this huge workshop. And I sometimes wonder why and how did we manage to lose the battle against the new material that was going to come. As I say, people have got this sort of ideas of quarry being still, maybe stone being hand cut and with hooks pulling the stone, and that's why it's so expensive. No, it's just that, oh, sorry, there is in fact 2 pictures of beautiful quarries. But anyway, here's 2 quarries. But in fact, quarries are highly mechanized. Here you've got huge pieces of stone already square, ready for shipping to one of maybe Gilles Perraudin project or Carl new venture in stone. So you see, it's got everything for it. It's easy to extract nowadays. We've got legislation to look after the way stone is being extracted. It's a well serious and still very much busy sector. As you can see, large machine in different quarries all around the world just safely extract stone, and you can see these massive blocks ready to be installed for a new build. So I think, what the beauty about stone is that you cannot only extract it from the quarry, but you can recycle as well. All around Rome, France, Spain, Greece, you can see incredible testament of the use of stone and reuse of stone. Here on the left-hand side, the Pise Cathedral with this incredible recovered stone from the Colosseum, the local Colosseum, was been, reused as another quarry. And on the other page, on the right-hand side, you can see already in the 1900 building in New York or Chicago being reused, even 50 years after. Instead of dismantling, they were just recutting stone from old buildings. So yes, as I was saying, how come suddenly stone became so irrelevant? Well, the very first thing is to think that with the advance of steel and concrete, stone started to be, because it was not man-made and had this sort of control, the lack of control of quality. I think people started to say, well, at least with steel or concrete, we can monitor this, the strength, the rigidity of the material. And so little by little, like on the flat iron here, you can see it's still it's self-load bearing stone, but it doesn't support the structure. You've got a grid of metal behind that would just take all the load. And as the steel was getting bigger, the stone was getting thinner. And on Poultry Lane, the remarkable work of Mr. Sterling is an incredible testament to the POMO movement and the cladding of structure just using thin stone. One of the biggest one is, for us in France, is the Chemetov incredible cladding of the Palais du Ministère de la Finance in France. And you can see that in the 90s, 80s, stone became just a cladding material. And people started to forget about the incredible facility that were being built to shape stone as is any shape, using wire saws, giant saws, circular saw, to give any shape to stone. as well as, of course, working stone by hand. It's still be done by craftsmen all around the world. They are using safe equipments. They are using electro-portative cutters, and they love doing it, days in, days out, shaping stone and making it available for next new build. So at the Stonemasonry Company, we started, a long trip 10 years ago, and we started to look around. And so from 1994, a resurgence of stone, especially in Britain, as a load-bearing material, with the work of Michael Hopkins on the left-hand side, the portcullis house made of stacked sandstone block that are post-tension. And this gets us thinking about using stone, reusing stone as a material, as a load-bearing material. And we could see at Gare Saint-Charles on the right-hand side that stone could still be, didn't need to be hollowed out and have some steel threaded through it. And it could be just big blocks of solid stone with just a simple hole and a tension cable to put back the compression in the structure. People tend to forget some key work of modern architects. On the left-hand side, you've got the incredible Padre Pio church with this seismic resistance load-bearing arches that is holding the roof. This massive arch of nearly 50 meters across are really putting back stone as a load-bearing material. On the right-hand side, Eric Parry Finsbury work. Eric Parry has been using a lot of stone, solid stone, just carry on being true to the material. And I think it's a testament to some of the incredible work done by architects who really truly believe and are committed to build in stone. Building in stone means that a good knowledge of geometry, a good knowledge of what we call in our trade stereotomy, the art of cutting volume in Greek. And since the 16th century, or in France, we've been looking at carrying on the subtle art of how to shape stone to make it, creating some amazing vault here in near Martigues in south of France, a brand new vault installed by a local stonemason. And of course, as we dig into the past, we cannot think about stone without looking at the Fernand Pouillon work in France. And it's with great sadness that when we stonemason look on this amazing quarry, which was working flat out during the 60s, the 70s in France, just to build cheaply and quickly this incredible work from Fernand Pouillon. So as I said, this little group of stonemason, we decided to inquire into the way that stone could be reused. As Valérie touched it a few minutes ago, there is an incredible lack of knowledge on how stone can react to different loading, stresses, and so on. And if we want to make it available again, we need to come to a sort of graded system, like it has been done in other natural material like wood, sorry. And testing and torturing stone to some awful effect, even if Steve Webb on the picture seems to be quite scared of what he just done. We just decided to make it available to the whole public and post-tension all our stone staircase, just to show that you didn't have concrete to make a self-load-bearing structure. And from 10 years ago, where we had this staircase with many cables going through and so on. We have reached now a level of stone art that can be used with our fantastic stone staircase here, with just a single cable going through the spine-like staircase. Another incredible work done with Webb and Yates engineer for undercover architect. The people who listening to me, of course, are and we'll hear about the work by Amin and the Clerkenwell 15 Clerkenwell Close that we helped develop, supply and fit. An incredible adventure and such a pleasure to fit this raw block of time on top of each other. So from now 10 years after this long path, we just think it's time after the time of austerity of Fernand Pouillon to use stone as just a simple material. I think it's time, looking at the past, at cities like Lyon, to suddenly realize that stone should, coming back from being a material of using for the luxury of people, to go back as a commodity. It should be widely used. It should be democratized. That only can be done if quarries like Polycor, like plenty of other quarries in Europe, decide to put some skin in the game and decide to reuse stone as a load-bearing material, just to simplify the whole facade and building system. If you were coming to the Stonemasonry company now, you would see that we are starting our new chain of manufacturing to produce post-tension, reinforced or pre-tension stonework. We have got plenty of work coming our way where architect, designers, engineers start to say, well, you know, let's look at how we build. I think it's time to press the pause button and just reset a bit what we are doing. There is so much thing that can be done if all people, architects, engineer, and craftsmen talk together. Here, some incredible view of blocks waiting for you, architects, engineers, to come and choose your block to start to build a new architecture in stone. For us, it's simple. It's going to start by our office. That will be a full load-bearing stone structure, just to show that yes, you can build in safely using stone just straight from the ground, very little manufacture on it, like Gilles Perraudin has been doing for the last 30 years. And that's it. So I think for me it's time to give the mic to my other friends curators. So I don't know who's next. I think it's Steve Webb. So Steve,
say a few words first, Pierre, before I interrupt.
Okay.
It's great to hear you speaking about shaping stone, actually, and I think your presentation shows the kind of versatility of stone. Yes, and it was really joyful to see the picture of Clerkenwell Close with the raw finishing there, the ammonite shells and the quartz pockets and seams. So that's a very nice link, actually, to the, as you say, to the second part of the Holy Trinity of curators. So I think we are going to hand over to Steve Webb now, who is co-founder of Webb Yates Engineers. And Steve pioneered the practice's approach to innovation and sustainability. So yeah, thank you so much, Pierre. And I think we're going to hand over now to Steve.
Thank you all. Thank you.
Yeah, I think you need to unshare.
Yeah, stop being so sharing, please, Pierre.
Okay. Sorry, I won't share my love anymore.
Or you do it again, maybe.
Here we are, Steve Webb. Thank you.
Hello, everybody.
Start sharing.
Yeah. Yes, I'm going to be much quicker than that. We can make all kinds of things out of stone. Some of the stairs and things that you've seen Pierre showing, quite adventurous structurally. The thing that was outside the building center on the screen is very simple to make a pre-stressed stone beam, span quite a long way at a reasonable depth, reasonably simply. I think it's clear to everybody that pulling stone out of quarries and using it consumes a lot less energy and CO2 than taking limestone out and crushing it, turning it into, burning it, turning it into cement, and all the different processes that are involved in reinforced concrete. But people are often quite arrested by the assertion that stone is a sustainable material because they say, oh, it takes 25 million years to make. Who's going to make the new stone? So yeah, clearly global stone, volcanic stone production. In fact, I can imagine that volcanic stone production globally is a massive amount of stone that's made every day. But what I wanted to say really was the ridiculous proportions, the smallness of what we build compared to kind of geological volumes. So people say, you know, you really, you know, we have an agenda to promote stone as a kind of interesting new sustainable material, rediscover it from its past, etc., etc. People say, you're really advocating that we'll build everything out of stone in the future. And I have to say that's not particularly what I'm advocating personally, but I was kind of interested. I was in Edinburgh, and there are many cities around the world, around Britain like this, huge city built out of stone, lots and lots of structural stone all over the city, massive volumes of stone. Where did it all come from? When you, I was kind of researching this, the new town came from the Craigleith quarry, which is just to the west of Edinburgh. And this is a picture of the Craigleith quarry with Edinburgh in the background. That quarry is now East Edinburgh, West Edinburgh Sainsbury's retail park, this little thing here. So it's underneath the car park of those shops. If we zoom out from Edinburgh, you can see my mouse, that's it. This is the kind of built area that came out of that hole. If you zoom out a bit further, look at the wider context of Edinburgh, you can see, you know, you can barely see that Sainsbury's. Actually, what you can see, all these dark green squares all over the map, it's forestry. The forestry is quite, you know, really prevalent in Scotland, has a very big impact on the countryside, and it's a big, big area. All the little brown squares, Weetabix. So you can see that really, you know, excavating stone for building has a relatively small impact on a kind of map scale. Also kind of interested to think about like the relative merits. So I don't think we should really have a timber versus stone competition in sustainability terms, but I think it's interesting to consider the two things side by side. So here's a tree. The volume of the trunk of a tree, about 1.5 meters cubed, maybe 75% of it recoverable, has a strength of 7.5 newtons. Takes 25 years to grow on a 5 meter by 5 meter patch. 0.336 meters cubed newtons per year. So this is kind of maths comedy. Below the tree, the photograph on the right, 5 by 5 meters of limestone, 20 meters deep, 500 cubic meters at 75% recoverable at 150 newtons, 224,000 meter cube newtons per year. So down here is a little dot of the wood, and here's the kind of stone yield that you get from the same land area. So yeah, if everyone in the world, and this isn't true obviously, but if everyone in the world had 5 by 5 meters of 200 millimeter thick concrete slab, 7 billion people, we would have 35 cubic kilometers of concrete or stone or whatever we choose to build out of. That's a whole, all of the buildings in the world for 25 square meters of concrete slab for every single person in the world, which they certainly don't have, I have to say, would be a whole 42 by 42 by 20 meters deep, 42 kilometers, a spec, a total spec. So that's, yeah, that's it. I thought I'd just keep it short and succinct and focus on that.
Thanks, Steve. I think the beauty of the exhibition actually, and the whole sort of exercise in understanding the potential of stone, was seeing the stone canopy outside and seeing that sort of slab of stone and how that could be used in a way that I think made it very immediate for people to understand the sort of benefit of and the sustainability of using stone. And I should say, for all of you that haven't realized, that it really was a holy trinity, curators, because I think the importance in the story is actually the kind of incredible work you can get when architect, engineer and craftsperson, the stonemason, work together. And I think that was a real success of the show. So thanks, Steve, for explaining the science to us. I might need to go back and watch that when we do post those videos so that I fully understand it. And if I was testing, I'd be able to get the answers right. So next up is Carl Frederick Svenstedt. We had his beautiful Dallas Winery project in the exhibition. It captured a lot of people's imagination in the show. And I'm not saying we're entirely responsible for this, but you have just been shortlisted for the Design Awards 2020 for the Dallas Winery. It's a fantastic project and we wish you luck. Obviously, we're massive fans of your work, Frederick. So over to you.
I can do that little symbol that you always put on Instagram. Well, thank you for that introduction. And I guess maybe I will, when we had a little event in July, surprisingly, on site in London, and I was able to come over briefly, and I said a few words, and I'm more or less going to repeat what I told you then. So if people were there, you'll have pictures this time. And I'm going to tell maybe a little bit of a personal story about stone. I'm Swedish and Canadian, but I've been in France for over half of my life. And surprisingly, for someone who comes from the north, I've spent a lot of time in the south. And I'm particularly happy to see that Gilles Perraudin is going to partake in this event, because I've, of course, been inspired by some of his work as well. So let me show you some pictures and tell you a little bit, a brief story about my own personal discovery of stone, which happened here, which is the Pont du Gard in the south of France, a Roman aqueduct. And I had an experience when I was down there in the parking lots. There are lots of blocks of stone lying around. And I suddenly had this feeling that this amazing stone that came basically from Roman quarries was just lying around. And so obviously had to be probably pretty affordable and reasonable to use. Then I got a project to build a house in the Luberon Valley, which is a protected natural site and where the building code is quite restrictive, and one had to make stone-colored buildings. So after toying with colored concrete and other ideas, I sort of put these two thoughts together and realized, having also seen other architects building with stone, for example, Gilles and some of his work, although I'd never seen any of them personally, that it was possible. And it turned out also to be affordable, which is to most people quite surprising. Basically, the first project was this idea that you just build like Lego. And you pile up the stone that comes in cubes, and you can move the stones a little bit, and you can create small windows and have a totally load-bearing building, which is incredibly adapted to the climate here, which is very hot. I also had another personal reference for that, which was that my parents and grandparents before them have lived a lot in the south, and we always stayed in the guest house, which was a new building, supposedly insulated, and were dying of heat. And we would walk into the old building with 50-centimeter thick walls, which was lovely and cool, even when all the doors were open. So we figured we could do the same thing here and build this house, which is open to the landscape. It has wide eaves to protect it from the sun, but basically the stone is such a qualitative material that it doesn't even need insulation or any extra material added, because the walls breathe and they work very well in this hot climate, even though it's quite cold in the winter as well. And oh yes, this is also the pool, which we can only build down there in places where there are already buildings, which is totally contradictory. So we built the pool into one of the ruins. So I also think it's important that you see the landscape from which the stone is coming from. This is not the Pont du Gard quarry, which is basically a Roman era quarry. This is Estallade in the Luberon Valley, but it's the same thing. The mountain has basically been slowly sawn down, taking up not too much earth, as Steve was saying. We built this winery, which in a way for me was almost like moving a mountain. There's a unconscious, which I only realized later, an unconscious link to that quarry. The blocks came out and we just piled them up, and that made a building. Of course, it's not that simple, but you know, a lot of thought went into it, but that's basically what's going on here, where you have a building where the walls, the internal structure is in concrete for reasons tied more to the way the building was made and the wide spans, but the outside walls are load bearing. As you can see, when you see how the windows are made, it's just stones piled on top of each other, which are twisted. And here you can see that length of that building, which all the stones are slightly twisted to give a sense of scale to this very big building in the landscape, which is partially buried to make a quality winery. Seen from the inside, you have protected, from the left to the right, you have a protected, sort of screened off harvest courtyard where the grapes can come in, and then they will go down through gravity, making better wine as they go down the hill. And again, this is the inside, so you can see the windows are just put in between the blocks of the wall that have been twisted to make an opening. And yet it's also a very functional space. This is the courtyard. And because they have visitors, they don't want visitors to see all of what's going on, but you can still look in. And the building was also conceived as a series of screens to protect the inside and to keep it cool and to protect it from the direct sun. And I have to be honest, I hadn't thought about what happened at night when it becomes a lantern, which was kind of magic. Again, back to the quarry. This is also the Estallade quarry. And to give you a sense of scale, you can see in this opening, this is what they call the office, actually, which is a hole in the mountain. And you can see the 2.5 meter high grate down in the center there. So this is about a 20 meter high opening in the mountain. And these spaces are absolutely inspiring and very much tied to the kind of emotion that one hopes might come out of a building. I'll now show you quickly De Les Frères, which is also very tied to the landscape. as the other project, which is called the Domaine Haute, was. This is the Rhone Valley, and there's this mountain which has a very favorably oriented hillside that's terraced for growing wine and makes some of the nicest wine in the Rhone Valley. And down in the village by the river, the town of Tain-l'Hermitage, a little off to the right, so you can't actually see it, is the site where we built, an existing site where we built the Delis Fair winery, which was an existing site with a manor house that we wanted to, that we renovated and wanted to, it was quite an imposing and not very happy building, to be honest. And it had a nice garden, but that was very run down. So we renovated the garden. And the idea was that the very big winery that we had to shoehorn into this urban site shouldn't be dominating and should also somehow become only the garden wall for the garden and the existing house. And that is why the winery, which is off to the left here, is behind this undulating wall, which when you come in from the street, which is on the right, you're looking at it face on, so you actually don't see most of the undulations, and it's quite a surprisingly discreet presence in the daytime when you come in. And what you see is the garden and the main house. And here's on the street side, we thickened the wall on the street, as it were, to make another building, a small building, which is the wine shop, which is also made using stone. This is not from the Estayade quarry, which the winery is. This is actually from the Fontvieille quarry, which was kind of wink to forebears in the stone construction in France. Notably Fernand Pouillon. It was the quarry that you saw pictured, that Pierre showed. The winery is, again, wineries are very technical buildings. They're a little bit like somewhere between a museum and a factory for making wine. Here you see a section which shows how this curved wall is the sort of interface of the whole project and has many functions, both spatially to create an interest from the garden and inside to create a passageway for the visitors who can come in behind the wall to see through windows in the middle what's going on in the winery, but without actually going in there. And the visitor space, oh, sorry, I'll get to that. The visitor space is top lit with direct sunlight, and the wall that is curved is reflecting the light indirectly into the working part of the winery without getting any sunlight on the wine itself, which is really bad for wine. There should be no sun. And this is the last step of how this wall was made. It was first quarried using stars in the quarry that came out as big square blocks that were then cut down, pre-cut using a wire saw, sort of band saw. And those blocks were then carved using a robot with a 3D, it's like not 3D printing, but 3D router. And each block is different. What's interesting is we modeled the wall. We gave that model to first the engineers of Stono, and who I should mention, who did a great job, and also to Olivier Chastel of Grain d'Orge, who cut the stone and his site, and we gave them our 3D model from the computer, which they then adjusted structurally and then used to carve each block. But the final phase was just these two guys, father and son, Eric and Manu Chaud from Printemps de Pierre, who laid all the blocks, which is quite an amazing thing with an incredible precision. And I also show this picture so you can get an idea of what's going on, because as you may have seen in the section, this curving wall is actually freestanding. It's cantilevered from the ground, and it's tied together laterally, horizontally. If you can see the grooves under his feet, there are cables, steel cables in there. And right behind where he's standing, there are holes, and those are the vertical post-stressing cables that will tie the blocks together down and anchor them to the foundations. Sorry, a little technical precision. And the result being this, which is a totally freestanding vertical wall. Its curving shape helps give it stability. And this is the public visitor space, and through the glass on the left is where the winery is. And so visitors can then go in and see the cask rooms and the steel tanks. And this is at night, this wall as it stands. And I'll stop there.
Thank you, Frederick. I mean, beautiful projects, really. And I think what's really lovely is to see the stone in the landscape and realize how suited that material is to building in that landscape. And as you talked about the emotion, which maybe is something we'll pick up later when we have our brief discussion after the presentations. One of the other great things for me in this exhibition was finding out more about the contemporary practices working in stone. People whose work rightly deserves a wider audience. So it's great to be able to show your work, Frederick, and also the work of Studiolada. Christophe Aubertin is going to talk to us now about the practices work. We had a very beautiful model of your circular structure, the tourist office in the Vosges region. And that was a piece of work that it seemed that lots of people stopped and looked at and marveled at that piece of architecture. So it's very lovely to have you with us this evening, Christophe. I'll hand over to you.
Hi, everybody. So I'm very happy to be here, and I was very proud to be in this exhibition with our small buildings. And so I will share my screen. I try. It's this, like this. Then I do that. Okay. So I'm going to talk about our practice. So I'm Christophe Aubertin from Studiolada. We are in France, in a quite small country in France. And the thematic is because we try to build with our local stone in the northeast of France and how to adapt the design with this stone. So this is a map of France with the different kind of stone that you can get. And we are in this part. So there is not, it is not like in the south, but we have stone anyway, and we have different kind. We have like limestone in this part, the white one, and also the yellow one in the north. And we also have like a sandstone and also granite. And we are interested in that because we think that if we use local stone, we have like environmental, it is more sustainable, okay, because there is less petrol consumption. But also it's very interesting to find a new historical and use of our resources in our area. So we think that we can invent a new architecture of each area according to the resources, material, but also the technical resources that we can find. So, for example, this is our area, and we have some buildings here in the area of the limestone. So we try to reduce the way from the carrier to the place where the building is. So these three are from limestone, and this one is from limestone, but this special one, yellow. If some of you know the city of Metz, this city of Metz is all built with this stone. It's very beautiful. And also in this part of the region, we use the sandstone, the pink sandstone here, for this small building that was exhibited in the exhibition. So I can say also that when I was student, I knew a lot about Gilles Perraudin. I can say that I am, and we are, a lot of architects like me, really admirer and follower of his work, because he's the one that start a new technical, a new way to build, and with this ecological practice, sustainable, but also a new design, a new architecture, a new material, a new light on the building. So that was my first building. It was like 8 years ago. It is health offices, and for this one we built it in wood, and we were in a region of stone, so we wanted absolutely to use stone, a massive stone in it. So we just built this wall inside, that you can see this inside wall in stone, and we had big beam in wood, crossing from this facade to this facade, and it is also on the wall here. Please, sorry for my English, because I really don't speak a good English. I try to do my best. So we wanted a big wall, but the better that we can do was a wall with 22 centimeters wide, because of the career, because of the price, because of many things. So we built this wall inside like this, but we were quite very happy to do it without concrete, without steel reinforcement, without how do you say, reinforced in the stone, and it is only stone and then the wood beam that come on it. And we just have this in the floor. It is to cut the cold, to stop the cold to come inside the building. You know, so this is cellular concrete. So we do like that. So we were quite happy to use it. And when it is inside, it's interesting because the wall can be visible on the two faces. So it's good. And also we use, I don't have a nice picture, but we use stone on the floor, and this we cannot use the local stone, but we use stone from Bourgogne, which is very hard and very easy to, very cheap also, and this is adapt for the floor. And that's it. So that was our first building in stone. And then some years after, we have a new building to do. So it is for a retired house for people retired. And we wanted to use also the local products, so wood and stone local. But we wanted to do it at the opposite, so to get the wood inside and the stone outside. So we build. So also I have to say that the budget and the money for this building is quite very classical, and we have to find solution for the economy. And so we wanted to do a new way to use stone with a cladding. We wanted to make a cladding using wood pieces like this, and then we put a small slide of stone like this coming inside the wood pieces. So we build the traditional wooden structure that we call ossature bois in French. So it is like a balloon frame with a panel, and then outside, without basement, we can put these pieces of wood and then the stone. And so the way then to put it is like this. So you can see the pieces of stone, It was quite difficult because this system doesn't exist, so we have to make a certification, a specific certification with the scientific center in French from the government, and then we have to do many studies to prove that this system is okay. Because the main problem was that the wood move, so you got some movement with in the future, but the stone cannot move. So you have to find you have to put some plastic pieces to don't break the stone when the wood will move a little bit. So this is the system. So you can see also that there is two kinds of stone. So this one is from Bourgogne, and the other one is from Meuse, so very close from the building. We make some tests we make some tests in laboratory to see if the system is efficient. But the problem was that always this stone in the top and in the bottom always break because it is not maintained like this one, who is maintained on the top and the bottom. So we tried many systems and it doesn't work. So we have to choose a better stone for this part. Also, this system is quite economic because the stone like this for the floor, it is a typical stone for floor, is only like 50 euros per square meters. So you can buy stones 50 euros per square meters, and after that, with the people that put it in the wall, so the global price of this cladding was 150 euros per square meters, and that is quite economical. So, and we love this kind of design according some wood pieces and stone. Then after that, we had a new building to design in Vosges. So the area is Vosges. So this is the area where I come from, where I have all my family, and we know in this area all the churches, all the institutional buildings use mainly this stone. This stone, so it is sandstone, pink sandstone, with a little bit, I can say, all like classical stone, but we wanted to use it in a contemporary design. So the beginning we wanted a circular building because of the function of the building. So it is touristic offices, and we tried this kind of design just with the circular. We have been in the beginning to meet the quarry with close from here, and with them we choose the size of the block. So the block is 140 centimeters, and it is 35 per 35. And then everything is really geometric. So we have 32 pieces of stone all around, and then we do that 32, and we have 10 blocks in the height. And so everything inside is in wood and outside is in stone. So somebody talked about the seismic condition. So this building is built in a seismic area. So also the circle form was a response to that, because this circle form is the one that is the more static and the more strong, because you have like angle all around the building. So we don't have we just have 4 reinforcement vertical. We have one here, and here and here, but also in the pillars. So all the pillars and the extremity of the walls get some steel reinforcement. And also horizontal, we just have, excuse me, for the vertical one, we have like 5 centimeters steel tube coming inside the stone. And for the horizontal one, we just have like a grid, flat grid of steel coming in the joint of the between the stones. So very economic for the horizontal one. And that is the design, very simple. I think everybody understands. We just have 20 centimeters on the top, 35 here, so we can put the timber pieces, and then we put the stone block like this. And this is the very simple and geometric design of this building. So like this. And the last one that I wanted to present is another building in the area of limestone. So this is a market, a new market in an old city with a lot of historical building. And there we wanted to use this stone, so we got a competition for this one, and we presented this design using limestone from the area and the wood. So it is all wood outside, all stone outside and wood inside. And we were very excited because I love the system of arch and vault. And when I started to use a stone, it was one of my goal, one of my dream to one day to use stone in an arch. So when we get this competition, we think it is the perfect condition to propose that. And so we propose this design with very big arch here, 24 centimeters. And inside, this is the wood structure. So it is also a geometrical design according to the arch. And about the arch, we knew the Renzo Piano building. So Padre Pio, Pierre talked about this one. So that was in our mind. And also we met a firm, a very interesting firm with SNBR, which is very close from the places of building. We visited their firm, and in their building they built by themselves this very nice arch, which is like 15 meters crossing in this space, in this place. So we think that we can propose a big arch. There is at least one firm who is able to do it. So this is the plan of the building, very simple. And that was the design during the competition. So you can see this big arch. First, for the competition, we propose a basket handle shape, because we wanted something which is not too much traditional. We wanted an arch, but a contemporary arch. We proposed this, and you can see the other one on the other facade, so the middle arch and the small one. And after that, during the studies, we changed the shape, and this is the final shape. So this is the, I don't know the name in English, but it is hyperbolic arch, I think. So it comes from there to there. You have concrete on the base, and then you have the arch. And this, the small one is also the same hyperbolic. The middle one is hyperbolic, and this one is hyperbolic. But you can see how the shape can change with that. So you can understand also here we have the same kind of Louis Kahn when he did this kind of brick arch with the concrete to maintain it. So you can understand that in the floor we have a very important pieces, which is a concrete and steel beam to maintain the traction of this big arch. And so we are starting the building, and now SNBR is starting to cut the pieces of stone. So you can see also these curved lines with that you can see here. So this is small details to improve the friction between the block and to make it stronger. And also I have to say that we don't have steel inside this arch. We really use the traditional arch with compression. We make a lot of studies to prove that we don't have to use steel inside. So this is with no steel, but we have a very technical steel here. This is the Freycinet system. Freycinet is a firm, engineering firm in France, and they have a system with a cable with really strong. So we have this system in the ground. So that is my last picture. So this is the end of my presentation. Thank you.
Thank you, Christophe.
Yes.
Really, really beautiful work. And I think we've heard so much about the kind of incredible properties of stone and the economy of working in stone. Perhaps if you unshare, Christophe, I can ask you and Frederick some questions about working with clients and then working with stone. So Christophe, because you're still there, thank you for the presentation. Are your clients very open to working in stone? Is it a material that you have to explain, or did you find that the clients of these great buildings were very, very up for your stone structures?
Actually, everybody loves stone. Everybody love it. Maybe it depends the kind of stone. I try to use granite because I was in an area of granite, and this stone is quite difficult to use because there is like this thinking of the tomb of the the grave to use it. So granite is quite used to build with, but the other stone, everybody love it. But there is a big problem, and this big problem is the money, the economy of stone. This is very difficult to find the good way to use it. That's why we try to use it in thin slide. We prefer to use it in massive block, but every time we have to. It is very difficult to find a good budget, and even the first buildings, the part of stone is quite a lot. I think we have a lot to do about the price. If we want to use stone much and much, we have to find solution to reduce the price. Really.
Yes. Well, I guess that's something Pierre and Valerie might be able to answer to, because it seems that it does so much in terms of sustainability, which is now more important than ever, I think. I mean, how can we address issues of cost if that's the problem? Valerie?
There's issue of cost, yes, it's there, but it's also to not only see the cost of building the building, but the maintenance and the life cycle of the building. And it's more and more involved in the conception of the building. And it's really education with the client to explain to them that, yes, it might be a little bit more expensive now, but in the long run, it makes a difference in terms of life cycle. And also in the quarry, we have to adjust the way we extract the stone. We are extracting the stone right now for a finishing product. We need to change that and to adjust it to do the finishing product, because that's the demand right now, but also for the load-bearing stone. It's two different ways to extract and to think about the product as well. So we're adjusting, but it's offer and demand. So we have to go with what is asked of us right now.
Mm-hmm. I mean, I see a very bright future for stone. And I think Frederick's, your building, your Dallas Winery, being shortlisted for the Design Awards can only help get the word out there. I mean, you're surely going to have people coming to you now demanding stone structures, but have you had, are those conversations difficult with clients about stone?
Well, in a way, yeah. The clients for the private house were delighted to do something different, and saw the immediate arguments for it being qualitative as a place to live. I mean, you put down a wall, you don't have to add all the other layers, and it's finished. And you have this amazing wall to look at. I mean, you just put the wall down and it's beautiful. So that was pretty easy. The wineries were more difficult. And I must say that the house was built 10 years ago and the cost was pretty reasonable too at the time. I have to say that prices have gone up, and part of that has to do with that there's maybe not enough demand to bring down the prices of stone either. If everybody was building, you know, there would be more quarries and sorry to say that, Valerie, but more competition and yeah, but that's
kind of competition.
Yeah, and so just to quickly finish, Pierre, I'll get to let you speak, but just the first time around for the Domaine Haute, which was the piled cubes, the client was perplexed about the idea of building with stone, but they had good sense to want to do something exceptional. And they also, being winemakers, were actually very conscious about the long-term vision and ready to make quality. So they paid a little bit more than if they had built a steel shed, but they have a very performative building that is going to last, you know, again, the quarry is, the stone quarry is, you know, 2,000 years old. I'm not saying the building will last 2,000 years, but, you know, it's probably got, you know, a good 100 years, let's hope. And I'll just add that for the Delas winery, indirectly, it's some of the same people involved as the Haute winery. And there they felt they didn't want to build another stone building. So I convinced them in the end, because they understood that we were doing something that basically hadn't been done before, or that, you know, there are examples, but, you know, it's sort of a different way of building, and it was a way to build differently. And I don't want to hog the speech time, but I should add one thing, which is more of a reflection for architects. Because using stone, there are all kinds of good arguments, but I wouldn't want it to become just a moral argument. It's about, I mean, really for me, it's about emotion. And this is such a beautiful material. And I'm glad to show with this building that, you know, we don't have to just do the sort of almost simplistic thing of taking a square block out of the ground and piling it up, which I thought was the only way to do it in the first time around, but that stone masons, and here I'll go back to Pierre, are delighted to be able to use their skill to do other things than just cubes piled on top of each other.
Mm-hmm. Yeah, I think just two things I wanted to touch base. One thing that was very touching by touching and sad by Christophe was that you need to prove that the stone arch works. You know, it's 4,000 years of knowledge in stone, and you need that you can have a stone arch that don't need metal restraint to stay up. It is totally madness. And the other part is about cost. The cost thing is that the stone industry is not geared to produce or mass produce stone elements for load-bearing buildings. Okay, they can do so many square meterage of cladding on 20 mil or 50 mil. Okay, at a cost that no one can touch because they are so good at it. But as soon as you change the rule of the game, you know, you need the industry to take time to suddenly say, okay, there is a new market. Let's get to it. Let's make stone buildings valuable again. So I think you saw that with the wood industry, a natural material industry. It took time for them to go from glulam, from big solid wood to then glulam to CLT. You know, it needs, we need to get to get down to it. We need to go back to the quarry and just speak with them. And that's why it's a whole synergy between quarries, between craftsmen, between architect and engineer, who just say, you know, that is possible at that cost. We can bring it to that cost. And the last thing is that clients don't realize the time wasted in project management of so many other trade just to do a wall of 250 mil thick. Okay, how many trade do they have to coordinate just to get a 250 mil thick wall? Okay, and believe me, the cost of a project manager is so much more expensive than the cost of stone. So they should look at this argument.
Yeah, can I bring in Amin there? You make the point. I mean, there's probably no one on I would say in the room, but we're in a digital, no one on our flat screen who knows more than you, perhaps at this moment, about the kind of emotion of using stone. And you say yourself, it's all about the kind of judicious use of stone. So perhaps you could say a little bit more about that. How do we best use stone?
Yeah. I think the conclusion we came to after, so this is after we've completed Clerkenwell. So step by step, there was a series of investigations, and really at the end of it, we discovered that it was cheaper and far greener. So we had some knowledge, but we didn't know exactly how much. So that first step with quantity surveyors and the entire design team sitting around the table, can we do a building in load-bearing stone? The initial answer was yes, you can, if you make it like the parliamentary offices or Eric Parry's Finsbury Square, which is quite a lot of engineering involved, i.e. it's all post-tensioned with other material interfaces. And obviously, parliamentary offices are notoriously expensive, and so is Finsbury Square. So most QSs will tell you, no, you can't do it for standard buildings, standard housing, standard offices. We talked to Pierre and other French stonemasons, and they very quickly told us in the post-war period, stone was called austerity construction because it was fairly inexpensive. So that first test, our British colleagues didn't have enough knowledge. We've lost it. So it's 100 years since we built in load-bearing stone. Quickly found out through our French colleagues that it's actually cheaper to build in stone than it is in steel or concrete frame, then clad it. Now, remember, the cladding, it also involves, as Pierre suggested, lots of other different trades. So you have to fireproof it, waterproof it, weather it, and then get your cladding systems to penetrate all that. So there are multiple trades. It adds time on site. Plus all those trades have to have their interfaces, their insurances and warranties and all the rest of it. So it's that build up. What you have to do is calculate, not just simply replace the structure of stone or even just the cladding of stone, one element at a time, but you have to persuade your quantity surveyor to take those sections of his cost plan book, which are separate paragraphs for substructure, superstructure, secondary structure, cladding, internal finish, external finish, all the rest of it, and sometimes just bolt the whole lot together and say, on balance, does that build up end up being cheaper, not just materially, labor, but time on site as well? And we found it's cheaper. So recently we did that research project with yourselves at the Building Center for a hypothetical 30-story tower. And Jackson Cole's quantity surveyors found that it was cheaper to build in stone a 30-story building, office building. It was meant to be your archetypal office building in stone superstructure than it is in steel or concrete. Carbon, again, we had an inkling. We didn't know all the figures. Our British design team, our sustainability engineers and environmental engineers initially said, look, we haven't done this before. Let's, as we go along, find out what the costs are, transportation costs and all the rest of it. So at the end of the project, they simply said to us, we've calculated it, you've saved 92% of the carbon footprint had you built this Clerkenwell Close in a steel frame. Now, we knew we were going to save something fairly significant, double figures, but not of that quantum. And they put the phone down saying, well, we'll leave you to work out how. And then, of course, it occurred to all of us as we're sitting discussing it, stone has 0 embodied carbon. The only energy you're using, the only carbon dioxide you're producing, is in its extraction on site out of the quarry, transportation and erection on site. So had we managed to source the stone from the UK quarry, we would have saved maybe 3% more. So not a significant amount just by transporting it from France. Now, the reason we couldn't do it from UK quarries is because none of the UK quarries had strength certificates that they could give us in time to get within our program. Nowadays, they're a bit more up to speed and they can give you the samples to test with short notice. I think that probably answers your question. I could ramble on.
Yes, well, we're going to hear a lot more from you later with Gilles Perraudin. So just bringing in our final question to Steve at the moment. Was it a big learning curve as an engineer then, working alongside Pierre and Amin? Was there sort of a very specific way that you had to look at the engineering of stone?
Yeah, I mean, I think we started working we were making wooden versions of stone cantilever stairs, and we were showing them to one of Pierre's friends, and he asked us if we could do the stone ones, because there aren't very many engineers that design traditional stone cantilever stairs. And we lied and said, yeah, of course, it's easy. And we kind of had to pick it up on the job. I mean, stone is a material like any other. It's not, there's nothing particularly magical about it. Limestone chemically is very similar to concrete. The issues are it's brittle and it's naturally occurring. So where most materials come with a kind of certificate and a stamp of compliance, you get a rock out of the ground and nobody really knows how effective it's going to be or how useful it's going to be. So it takes some bravery to work with stone. I think in terms of, I mean, there are millions of precedents for stone buildings, and using massive stone for walls and for arches in compression, there's nothing really that scary about using stone in compression. What's a little bit more frightening, I think, is using stone in tension, which we do sometimes, and how you approach that. But I think it's a material, and I don't think it's clear to me. I mean, there's a huge history of building in stone, and it's usually what Amin would call a traviated typology for Clerkenwell Close columns and lintels, way back through history, the same as brickwork and everything else. And I think now we have better methods of analysis at our disposal. There are no codes, there's no real certification, so a lot of this is needing to be invented by the engineers every time. But I think we have the ability to analyze and to understand and to test the stone, or non-destructively test the stone, and to use it in far more adventurous ways than just kind of big lumps on top of each other. And I think that you can see from all the different buildings that people are designing, there's no real cohesive typology. And I think at the kind of birth of many materials like concrete, talking to Amin about this, Maxwell Ayrton was designing the Empire exhibition with the new material concrete in 1920 with Owen Williams, the engineer, and he was designing it to look like stone. So he was designing neoclassical stone architecture with concrete. And Owen Williams got really fed up with him and walked off and designed boots, wets, and all sorts of other things out of concrete, because he realized that concrete needed a new language. And I think in many ways, stone is a new material. Stone is a new material to modern engineers and modern architects. It's new to us. And I think with our new kind of way of understanding materials and designing buildings, we have to find a language that's appropriate for stone. So I think big lumps of stone piled off on top of each other is completely valid. Arches and vaults and stuff have certain limitations. Reinforcing it, post-tensioning it, it's kind of emulating concrete in some ways. We were talking to Pierre about, actually our stone elements sticks like steel beams with bolted connections on the ends. Actually, we make stone Meccano sets and start bolting them together. There's so many different technological typologies, directions that stone could take in today's world, quite different from how it was built in the past. And I think perhaps if people use a certain a certain methodology will start to coalesce, and it will be adopted more widely and industrialized and more cost effective, as Pierre says, rather in the way that CLT has become to timber what the Hoover is to the vacuum cleaner. You know, I think, you know, perhaps if somebody invests in research and develops a system, there'll be a kind of McDonald's style stone production that we can lash all over the place and get completely bored of really quickly, but maybe do a little bit less damage to the planet in the process.
Yes. We're definitely not bored of stone yet. But on that note, actually, I will, we've had lots of questions through the question and answers, but we are unfortunately running out of time for this part of the evening, because we've got Gilles Perraudin in conversation with Amin up in 10 minutes time. We're going to have a 10-minute break, and it very much is very evident talking to all of you this evening that Gilles Perraudin has been a really big influence in stone architecture and using stone. So we're very much looking forward to hearing more from him. And that part of the event will be bilingual, and I'll talk you through that when we come back. So apologies, it seems that there's a lot of people from around the world watching us this evening. So big shout out to Rose Elstone in Spain, and Matty in Turkey, who is asking about seismic issues in using stone. I think we'll try and find an opportunity to get back to everybody. The building centre, it started off in the 1930s as a place where architects and students and engineers could see innovative materials. So we try to keep that tradition going through our public programme. There's lots of information that you can find out from the new Stone Age exhibition, from our curators' articles. So have a look on the website, see what you can see. But at that point, I might just say thank you to the participants of this roundtable. It was really brilliant to see your presentations. So thank you to Christophe and to Frederick for showing your work, and really look forward to seeing more of it. Thank you to our three curators, as always, Amin, Pierre and Steve. And thanks to Valerie and the support of Polycor. And very much looking forward to Gilles' presentation and speaking to Amin, because I think there's so much to be learned, so much to be relearned about stone. We look forward to seeing you all again in 10 minutes. So thank you, everybody. Thank you to our audience. Don't go away, stick with us. Lots more to come in 10 minutes.
Je suis en effet, en dehors de mon activité d'architecte, viticulteur, et je fais du vin. Et un jour, j'ai donc rencontré une pierre sur mon chemin, et comme cette pierre me demandait, comme je lui demandais ce qu'elle voulait être, elle m'a dit « je veux être un mur ». Alors j'ai fait un mur. Et c'est comme ça que j'ai commencé mon aventure avec cette pierre, et que j'ai construit le premier bâtiment. Comme vous l'avez vu, ça c'était moi en plus jeune, il y a donc maintenant 25 ans. Donc il y a 25 ans, j'ai commencé à construire en pierre par moi-même. Si je l'ai fait, c'est tout simplement parce que la plupart des gens à qui j'expliquais que j'allais construire en pierre massive me prenaient pour un fou. Donc, il a fallu que je me débrouille tout seul, et ça a été formidable parce que j'ai tout appris sur la pierre en faisant par moi-même ce bâtiment. Et comme j'étais enthousiaste après avoir fait ce premier bâtiment, je crois que beaucoup ont décrit les qualités que l'on peut ressentir quand on fréquente la pierre, sa douceur, sa présence. J'ai donc décidé de proposer pour un bâtiment, un collège, de le construire en pierre. On m'a fait confiance et, je le raconte souvent, ce bâtiment qui fait à peu près 4500 mètres carrés, et je l'ai construit en moins de 10 mois, depuis la conception jusqu'à la fin de la réalisation. C'est dire la rapidité que l'on peut attendre d'une construction en pierre. cette construction, je rappelle souvent, pardon, que quand on a commencé la construction sur le site, je me suis trouvé très rapidement en avance sur mon planning, car personne n'imaginait que la construction en pierre pouvait être une construction extrêmement rapide. Alors, enthousiasmé par ces expériences, j'ai décidé d'aller encore plus loin. Et j'ai proposé pour une ville la construction d'un immense bâtiment scolaire, un très grand collège, entièrement en pierre. J'ai appris à ce moment-là toutes les arcanes ou les difficultés et pierre par pierre, nous avons dessiné ce bâtiment. Il n'a pas été construit car le lobby des constructeurs traditionnels de béton se sont opposés à cette construction en convainquant les décideurs politiques qu'il était impossible de construire un tel bâtiment, ce qui était bien entendu complètement faux. Alors, j'ai poursuivi ce chemin avec ma pierre qui m'a accompagné et on a construit ici un bâtiment, une cave viticole à nouveau pour un client qui n'avait pas d'argent et qui pouvait simplement construire un bâtiment, une structure métallique couverte de tôle, et on lui a proposé de le faire entièrement en pierre massive. Ce qui fut fait dans les délais et dans les coûts d'un bâtiment très simple, comme une sorte de cathédrale, une nef, pour accueillir le vin. Vous savez combien en France on est attentif et on prend soin du vin. Puis, cet autre bâtiment, qui était là aussi, ce sont des arènes. Dans le sud de la France, on fait beaucoup des courses de taureaux. Ce n'est pas des corridas, on ne tue pas les animaux. Donc, ils sont simplement utilisés pour faire des joutes sportives. Et on a dessiné un bâtiment entièrement en pierre, donc on le voit. Une partie de la maquette qui est montrée, donc c'est un bâtiment assez important et qui devait résister aussi au sismique, tout en faisant aussi une toiture végétalisée comme une sorte de raquette avec un câble en tension qui venait comprimer toute la tête du mur de ce bâtiment. Ce bâtiment, alors je dois vous dire, et pour qu'on évite peut-être, mais je le redirai peut-être tout au long de mon exposé, à aucun moment, jamais, mais jamais, il n'y a un seul brin de béton armé ni d'acier dans mes édifices. Mes édifices sont entièrement construits en pierre massive et ils ne doivent leur stabilité qu'au fait qu'il y a une vraie pensée constructive et une pensée architecturale, donc des formes totalement adaptées à la stabilité à partir d'éléments donc singuliers. Et aussi, ça c'est à nouveau une cave viticole faite pour une communauté religieuse installée dans le sud de la France, où l'on voit comment le bâtiment est structuré de sorte à présenter donc une façade relativement opaque, mais en même temps avec une lumière qui pénètre à travers donc un mur fait de colonnes qui fait plus d'1 mètre d'épaisseur. Ce mur n'est absolument pas stable, il est simplement stabilisé par les murs intérieurs qui forment des croix et qui supportent la totalité donc des mouvements possibles de cet édifice. Alors peut-être que beaucoup se poseront la question de savoir comment j'arrive à construire tel bâtiment et comment je peux justifier qu'ils vont tenir. Alors, en réalité, pour être très sincère avec vous, je commence à construire. Je commence à construire le bâtiment et ensuite, je justifie bien. Voilà, ça c'est le chantier. Donc, on m'a souvent appelé aussi l'Égyptien, sans doute en référence au temple auquel peut faire penser cette architecture. Ça, c'est un autre bâtiment dans un registre différent. C'est un bâtiment de bureau qui est sur une structure en bois massif, donc là aussi, pas du lamellé-collé, que du bois naturel massif qui monte sur 25 mètres de hauteur et qui est posé sur un soubassement, comme on le voit ici, en pierre massive. Donc cette pierre vient supporter la totalité de l'édifice qui se trouve au-dessus. Les planchers sont également aussi en bois. Donc, toujours travail, on essaye d'utiliser au maximum les matériaux naturels, sans aucune utilisation de produits chimiques. Donc ici, par exemple, les bois sont des bois du mélèze, la pierre, bien entendu, et c'est l'une de ses grandes qualités, n'a pas besoin de traitement chimique. Donc ce sont des matériaux très sains. Ceci est une maison construite dans la ville de Lyon, dans un endroit extrêmement dense de construction. Le terrain était très étroit et on a dû encastrer en quelque sorte cette maison au milieu des immeubles. Elle nous a permis de démontrer que la construction en pierre autorisait des formes relativement complexes. Donc on le voit ici sur les éléments qui portent la toiture de la maison. Donc la maison est portée par ces éléments qui, en même temps, contiennent les services techniques et tout. C'est vrai qu'on a même encore, vous voyez, le travail qu'on peut faire ici à l'agence, où ce bloc que vous voyez sur l'écran est travaillé exactement comme une sculpture. Et ensuite, chaque élément de pierre est étudié pour effectivement réussir à réaliser cet ensemble. Il n'y a pas un seul morceau d'acier dans cette, comme vous voyez, les franchissements sont des franchissements très, on appelle un arc en plate-bande. Vous voyez que chaque pierre est donc dessinée avec ses angles, avec ses dimensions, la particularité de chacune de ces. Elles sont ensuite, comme on a pu le voir dans d'autres présentations tout à l'heure, découpées dans des ateliers, dans les carrières, et ensuite, comme un puzzle, les pierres sont montées donc les unes sur les autres. Ceci est un projet, donc bien sûr nous utilisons la pierre et on est considéré peut-être un peu de manière excessive comme les architectes de la pierre. En réalité, on utilise tous les matériaux naturels. Ceci est un très gros projet qui malheureusement ne s'est pas réalisé dans la plaine de la Beca, au courant d'un ensemble d'immeubles qui était entièrement construit en pierre, prise localement, puisqu'on trouve beaucoup de pierres. Ici, ce sont les montagnes du Liban, dans lesquelles se trouvent les carrières. Et comme on est dans la plaine de la Beca, on trouve beaucoup de terre. J'ai réalisé déjà quelques bâtiments en terre, car pour moi, de toute façon, la terre ou la pierre, c'est le même matériau. Ils sont tous les deux issus du substrat minéral qui couvre la terre entière. Ça, c'est un projet aussi pour une cave viticole dans le Bordelais. Donc, vous voyez qu'on a une relation assez forte avec les bâtiments viticoles qui trouvent dans la pierre une excellente source, des qualités qui permettent de satisfaire aux exigences de la fabrication du vin. Ceci est un musée du vin, encore, musée du vin construit en Corse avec des pierres qui font 60 cm d'épaisseur et qui, là encore une fois, ne reçoivent strictement aucune structure complémentaire d'acier ou de béton. C'est d'ailleurs l'étoile. Alors, bien sûr, je pourrais parler longuement de l'architecture, de l'inertie de la pierre, de ses qualités thermiques et, bien entendu, l'eau que l'on voit qui parcourt des bassins qui sont tout autour des bâtiments sont là aussi pour rafraîchir, apporter un confort naturel à cette construction. Vous voyez que les toitures sont également en bois. Ce sont des bois locaux. C'est ce qu'on appelle du pin lariccio, qui est un pin qu'on trouve, un arbre qu'on trouve donc en Corse de manière endémique. Donc on ne le trouve qu'en Corse. Et vous voyez que nos structures sont toujours très simples et très souples. On reviendra sur cette question parce que je sais qu'elle est parfois au cœur des questions qui sont posées sur la pierre, c'est la question du sismique. L'intérêt de la construction en pierre, pour autant bien sûr qu'elle ne contienne pas de béton armé ou d'acier, est une construction souple. Et elle s'accorde parfaitement avec des structures en bois qui sont elles aussi des structures souples. C'est cette souplesse qui est utilisée d'ailleurs depuis la nuit des temps par nos ancêtres, qui permet de s'opposer de la meilleure façon aux problèmes sismiques. Vous voyez la construction, c'est toujours une construction d'une extrême simplicité, c'est toujours ça dans nos objectifs. On fait des constructions qui utilisent un format souvent unique de pierre, et les pierres tiennent les unes sur les autres, tout simplement par leur poids. Et j'ai vu qu'il y avait des questions sur les mortiers qui sont utilisés pour assembler ces pierres. Ces mortiers n'ont d'utilité que pour assurer l'étanchéité à l'air. Et je dois vous dire que le premier bâtiment que j'ai construit et que je vais vous montrer tout à fait au début, ma cave viticole, est construite sans mortier. Les pierres sont simplement assemblées à sec, comme on dit, c'est-à-dire les pierres sont posées tout simplement les unes sur les autres. Ceci est un bâtiment aussi d'une certaine importance. Il y a à peu près 10 000 m² de bâtiment. C'est une grande cave viticole doublée d'un bâtiment d'hôtellerie avec donc, tous les services aussi pour d'organisation de séminaires et toute une série de lodges autour d'un spa. Et on est ici donc en Roumanie, on est sur les bords du Danube, proche de la mer Noire. Donc ce bâtiment est en cours de chantier, comme vous le voyez, donc tout l'ensemble est entièrement en pierre massive. Alors on voit ici quelques images qui datent un petit peu maintenant de ce bâtiment inséré très, très subtilement dans l'environnement. Alors là, je passerai peut-être un peu rapidement. Il s'agit d'un projet qui est plus une sculpture. Il s'agit de jardins mystiques. Je ne vais pas trop vite, non?
Non.
Sont des jardins mystiques pour l'abbaye de Cîteaux. Donc, vous savez que les cisterciens sont des congrégations religieuses qui ont une pratique, disons, dans la sobriété, l'extrême sobriété. Et ce bâtiment a été imaginé, comme on le voit sur le plan, pour accueillir et faire ressentir la dimension mystique de l'abbaye autour de l'utilisation donc de la pierre et bien sûr de la rose qui est le symbole de la Vierge Marie dans le jardin mystique médiévaux. Et puis, bien sûr, on s'est intéressé à la construction de bâtiments, de logements sociaux. Donc, ça, c'est le premier bâtiment que nous avons réalisé en pierre massive, là aussi, bien sûr, sans aucun renforcement. Je vous le dirai des tas de fois parce que pour moi, c'est une question clé dans l'avenir de la pierre. Il faut absolument que la pierre puisse être utilisée sans aucun renforcement d'aucune sorte. Sinon, on aura perdu notre pari de réhabiliter la pierre. Donc voici ces logements. Donc là aussi, toujours, construction en pierre massive, des volets qui sont en bois non traité, qui vieillissent naturellement, et bien sûr des logements traversants sur toute l'épaisseur du bâtiment, et qui offrent aux habitants des niveaux de prestation et de qualité absolument incomparables, puisqu'on est entièrement dans la pierre, donc avec les qualités thermiques qu'on peut imaginer, et surtout des qualités de vieillissement. Donc ça, c'était le bâtiment après quelques années, donc il y a un vieillissement qui apparaît et qui donne à ces architectures une vraie qualité irremplaçable. Ça, c'est une image qui illustre, après avoir construit ce premier bâtiment, on a donc construit tout cet ensemble. Ici, il y a plus d'une centaine de logements qui ont été construits en à peu près une année. Donc, on a parlé tout à l'heure des capacités des carrières. Ici, une des carrières avec lesquelles on travaille a fourni de l'ordre de 10 000 mètres cubes de pierre sur l'année. Certes, c'est une question, j'ai vu qu'elle était soulevée tout à l'heure, c'est une question effectivement pour trouver des carrières qui ont cette capacité. Donc ces bâtiments, encore une fois, entièrement en pierre, sont des bâtiments d'une très grande simplicité. Il faut savoir que pour atteindre les coûts qui sont ceux du logement social, on doit travailler sur des designs, on va dire, sur des formes qui sont d'une extrême sobriété. Tout est dicté par le matériau, par la pierre, par la base avec laquelle on travaille. Donc, vous voyez, il y a un ensemble, il y a des petits collectifs, comme on a vu ici. On a aussi des maisons individuelles groupées. Donc, vous voyez qu'on utilise, tout est en pierre, systématiquement, voilà, pierre et bois, bien sûr, puisque c'est quand même les deux matériaux avec lesquels on travaille le plus. On ne renonce pas à laisser la pierre s'exprimer. Je sais que d'autres l'ont fait dans leur bâtiment, s'exprimer dans sa, j'allais dire, dans sa brutalité, c'est-à-dire comme elle vient, comme elle sort depuis la taille dans les ateliers, des carrières. Donc, ces pierres, comme vous voyez, portent les marques des grandes scies qui les découpent. Et l'on voit bien que sous le soleil, on a des jeux d'ombre qui sont extrêmement intéressants. Mais ça ne suffisait pas de démontrer que faire 120 logements en pierre massive était possible en une année. On a décidé de montrer qu'il n'y avait pas de limite. Il n'y a aucune limite à monter des bâtiments sur la grande hauteur. Ici est une cour. Imaginez pour la ville de Genève, une tour multi-usage avec une partie au rez-de-chaussée de service, puis une partie bureau au-dessus, et enfin, tout à fait en haut, une partie logement. Donc cette tour qui a failli gagner le concours pour lequel on participait démontre qu'on peut imaginer des bâtiments entièrement en pierre sans aucun élément complexe de structure, en s'appuyant sur ce qu'on sait de la pierre, comme celle d'optimiser, comme on le voit ici, la matière. Donc plus on va monter, plus la pierre peut se réduire, voire changer de nature, pour obtenir d'avoir des pierres ici tout en haut plus légères que celles qu'on a en bas. Les systèmes de reprise de charge, si on a des murs en pierre au-dessus, des reprises de charge toutes simples sur des arcs de pierre, et on peut monter ici. La tour fait 65 mètres de haut, ce qui est relativement modeste. À une question qu'on me posait récemment pour me dire, mais on ne pourrait plus construire des choses comme ça dans nos villes, j'ai répondu que il y avait déjà 2 tours à Paris qui faisaient 65 mètres de haut. Et ce sont les 2 tours de Notre-Dame. Donc, tout est possible pour monter sur ces hauteurs. Ceci aussi sont des projets présentés des concours qui n'ont pas abouti, mais on voit toutes les capacités de construction en pierre. Ici, encore une fois, on a des programmes de logement avec des parties aussi communes ou de services sur les rez-de-chaussée. Également aussi un autre bâtiment, alors là, et ça peut effectivement apporter des réflexions. Ici, le bâtiment est construit en gneiss. Donc le gneiss, c'est, on va dire, une sorte de granit métamorphique. Et on voit qu'on peut effectivement, avec de telles structures, telles pierres, réaliser des structures qui peuvent être, en apparence, en tous les cas, d'une certaine légèreté et franchir des espaces. Ici, on est bien sûr dans une cave viticole qui suppose aussi d'avoir ce qu'on appelle des grandes hauteurs sous le plafond. On voit bien que la pierre permet et autorise des formes relativement complexes. Ça, c'est un projet, je passe rapidement aussi, un ensemble de centres de congrès et de bureaux pour la ville de Genève. Et puis aussi, on s'intéresse à des toutes petites choses. Ici, c'est une maison individuelle construite dans le sud de la France, et qui est elle aussi entièrement en pierre massive. Donc une maison très économique. Les habitants avaient un budget extrêmement limité et on a donc imaginé une construction extrêmement dense, très simple, basée sur un carré à la base et à l'intérieur d'une grande ouverture, d'une grande transparence, puisqu'on est ouvert tout à fait vers le sud pour prendre le soleil. Et donc, voilà, ce bâtiment très très simple, toujours comme on peut le voir, des structures en bois, parce qu'il y a un mariage absolument convaincant, je vais dire, entre la pierre et le bois, parce que les deux sont des éléments de grande souplesse. Et il y a d'ailleurs eu un tremblement de terre l'été dernier, je pense que c'était l'été dernier. Dans cette région, beaucoup de bâtiments en béton ont été fissurés. Cette bâtisse ici n'a eu simplement que quelques joints légèrement fissurés, et que notre client s'est empressé de reboucher. Comme vous pouvez le voir et comme vous l'avez compris, le travail de l'architecte vient soudain empiéter sur celui de l'ingénieur. C'est-à-dire que l'utilisation de la pierre redéfinit totalement les rapports entre architecte et ingénieur. Puisque si on utilise des figures de stabilité, des figures constructives, donc qui sont stables, nul besoin d'avoir des calculs complexes pour faire valoir la stabilité de ces édifices. C'est d'ailleurs toujours à partir du moment où on commence à poser la question à un ingénieur de faire tenir un bâtiment en pierre qu'on a tous les problèmes du monde. Donc, vous voyez, je suis un petit peu provocant pour entraîner un débat sur cette question. Et bien sûr, tout ça nous a amené à construire des bâtiments là aussi plus importants. Donc, ce sont 2 bâtiments construits qui sont en cours de construction aujourd'hui dans la banlieue de Genève, des bâtiments qui font 8 niveaux au maximum et qui sont donc entièrement en pierre massive là aussi. Ça, je ne sais pas si vous pouvez le voir, on peut zoomer un peu. Non, ça marche pas. Si. Voilà, donc voilà le type de travail que nous faisons, c'est-à-dire que pierre par pierre, nous dessinons donc tout l'édifice. Là, il y a 7000 blocs, hein, c'est ça. Et 7000 blocs qui forment... Ah, pardon, on a un petit souci. Voilà, on revient. 7000 blocs, et comme vous le voyez, tous les éléments porteurs de l'édifice, depuis la façade extérieure, comme les noyaux ici qui sont à l'intérieur, on les devine plus qu'on les voit, sont entièrement donc en pierre. Bien sûr, comme toujours, travail sur les calpinages. Vous voyez les franchissements qui sont systématiquement en arc plat, arc de plein cintre, comme on appelle. Et bien sûr, il est clair que quand on fait une ouverture dans une façade comme ce bâtiment, on sait qu'on ne peut pas dépasser certaines limites, au-delà desquelles, effectivement, on serait contraint d'utiliser des systèmes plus sophistiqués de construction, ce à quoi on se refuse, bien sûr. Voilà le bâtiment en chantier. Donc, vous voyez que ça implique un stock de pierres relativement important. Et ici, donc, on doit avoir, je ne sais plus combien de mètres cubes. 3000 ? Non, pas 3000 mètres cubes. En tout 7000 blocs qui doivent faire 3 à 4000 mètres cubes, c'est ça ? Oui, c'est ça. Bon, enfin, bon, bref. Des chiffres qu'on peut vous calculer si vous voulez. Voilà le bâtiment, donc en cours de construction, l'un des 2 bâtiments en cours de construction. C'est important. Donc, alors là aussi, donc, vous voyez les noyaux intérieurs entièrement donc en pierre massive. Vous voyez rien à part les planchers qui sont en béton. Alors, c'est intéressant, effectivement. Les corniches aussi qui permettent de garder les façades les plus propres possibles, puisque les ruissellements à ce moment-là se font sur la corniche et vont éviter de trop impacter sur la qualité des façades en pierre. Vous dire que ce projet aussi a été imaginé, alors je reviens un petit peu en arrière, a été imaginé aussi les planchers entre ici les noyaux intérieurs et la façade extérieure ont été au départ imaginés entièrement en bois. Et comme on est dans une région sismique, hein, bien sûr, toutes les Alpes sont dans des zones sismiques, on a travaillé avec un ingénieur spécialisé dans le sismique, un ingénieur suisse, et lorsqu'on lui a présenté le projet, il a simplement dit « Vous avez fait en pierre et en bois, c'est parfait. on ne peut pas faire mieux pour le sismique. Voilà, donc si certains veulent des réponses, vous les avez. Et puis aussi, ce bâtiment en cours de construction à Lyon. Donc, c'est dommage que Amin n'ait pas pu, je l'aurais fait visiter le chantier si j'avais été là. Et ce bâtiment est un bâtiment qui superpose un atelier de menuiserie, des bureaux et 3 niveaux de logement, dont des duplex pour les 2 parties hautes. Ce bâtiment est bien sûr entièrement en pierre. On voit le chantier, là vous voyez l'image, ça c'est le chantier qui est en cours aujourd'hui. Donc, entièrement bien sûr en pierre. On voit là une pierre en train d'être posée là-haut. C'est des photos relativement récentes. Et à l'intérieur, les franchissements pour éviter d'utiliser trop de béton, parce que malheureusement le béton, les réglementations en France nous obligent à utiliser du béton pour des raisons strictement acoustiques. La législation, certainement faite sous la pression des lobbies du béton, permet d'atteindre des performances acoustiques avec des hauteurs relativement faibles. Si vous utilisez du bois, ce qui serait une meilleure solution, ce bois entraîne à des hauteurs de plancher qui ensuite ont des conséquences sur la hauteur totale de l'immeuble et nous font finalement ne pas pouvoir le faire à cause de ces réglementations. Donc vous voyez, les constructions chez nous sont d'une grande simplicité. On aurait pu les faire évidemment au Moyen-Âge. Bon, mais elles sont contemporaines. Voilà, on pose une pierre tout simplement sur l'autre et ça suffit. Voilà une autre image qui montre bien comment on peut, avec des éléments en pierre, avec la pierre massive, comme cela, faire des bâtiments très contemporains et qui ont des qualités, je pense que peut-être on pourra en parler dans le débat, des qualités qui sont incomparables, surtout pour diminuer l'empreinte carbone, puisque c'est quand même la raison principale pour laquelle nous construisons en pierre, c'est de diminuer l'empreinte carbone des bâtiments. On sait que cette empreinte carbone est la clé de la diminution de l'impact climatique dû aux émissions de CO2. Donc, il y a une nécessité absolue à devoir reconstruire en pierre pour éviter les dépenses énergétiques que font les bâtiments contemporains qui sont en béton, en acier et autres plastiques, et j'en passe. Alors ça, c'est des premiers. Bon, peut-être qu'on va débattre après. Merci de votre attention. Et
thank you, Gilles. I don't think we need to debate the saving of carbon. I think all of us have that ambition. I mean, interestingly, here that project, that research project, demonstrated, yes, stone alone, all stone construction. So you're using stone for the external, the superstructure, the external finish, and even internal floor plates. Obviously saves a great deal of carbon, up to sort of 90 odd %, depending on the type of building. But if you combine it, as you have done in some projects with timber, the timber is obviously a carbon negative. And if you combine it correctly enough, then your building can be so carbon negative it's more carbon negative than the equivalent steel frame structure that's clad in stone, etc. is positive. Making the argument for demolishing existing steel frame structures and replacing them with stone and timber and still being carbon negative. Now, obviously, a new building like that is obviously better thermally insulated, has longevity, and therefore its long-term carbon equation, apart from having better embodied levels, is also better. Now, from your discussion, I've got lots of questions, but I think I'll start off with. I mean, ultimately, the people listening, I'm hoping the purpose of today's talk is not just to introduce them to your very good work and yourself, but actually they all go away trying their best to see whether the buildings they've got on the drawing board at the moment, new buildings that are coming in, can be in their various countries, their various regions, structures, the concrete or steel structures can be substituted for stone. It's always a challenge. It's a challenge in this country. And I'm glad to see you've got pretty big buildings in France being put up by large contractors, multi-story buildings, multi-use buildings. You started off with the wineries, you had some housing, office buildings and multi-purpose buildings now. My first question, I've got a technical question which is to do with weathering. So everybody across, whoever's listening in different parts of the world, can deal with weathering. So that's the thermal insulation as well as waterproofing of multi-story buildings. So obviously they're not wineries anymore, they are housing and offices. Can you just tell us a little bit about that? And then also how your experience with main contractors, large contractors, because even today we had a meeting in this office with a contractor who's building a large house for us, hoping to build a large house, but they're still nervous. We've asked our stone masons to demonstrate to them how it's possible, but as a main contractor in this country, whether it's an office building, a large residential building, or even a house, the main contractor is still nervous. How have you managed to persuade your main contractors, and are there enough of them? Are there enough large ones that we might be able to even persuade them to come to this country? So first of all, the details, the thermal and waterproofing details.
Oui, j'ai à peu près compris la question.
Okay.
Bon, il y a beaucoup de questions. Alors, je vais peut-être répondre par la dernière parce qu'elle est peut-être la plus simple.
Maybe I will answer the second question. My son says, no, whatever the case, you don't give us a choice. He builds in stone, and that's it.
En réalité, j'ai réussi à convaincre beaucoup d'entreprises.
In reality, I was able to convince a number of companies that the construction wasn't in stone. If you tell them it's stone, you've lost. We simply say, we tell them I built a building made of pre-made concrete, natural pre-made concrete. Prefabricated concrete. They understood.
Oh my God!
And so if they weren't convinced by that, I would mash the table.
Voilà, ça c'est pour la première question.
I've tried. You know, I've tried that.
Il faudra essayer.
Not so successful.
Il faut essayer.
Yeah, oh dear.
Ah,
okay.
ben,
Right.
il faut venir plus nombreux comme architecte.
Right, I'm not sure that's going to really help. Yeah, I'm not, okay, fine. All right. I mean, it's a sort of rhetorical question. I think every architect out there is going to have to persuade their contractors, their clients to go for stone. Perhaps he can answer it in another way. The way we persuaded clients was to bring with us the stonemasons to meetings with the project team and demonstrate it would be cheaper, quicker to build on site. So once we demonstrated the savings might be above 10%, sometimes 25%, almost all clients push any contractor to head in that direction. I'm looking at your buildings and I can see you're using very large pieces of stone, and it depends which quarry you go to. Is that mostly to do with your optimization of pieces to get the cost down and get the time on site down as well?
C'est un élément important. Je dois vous rappeler que quand j'ai construit mon premier bâtiment, je l'ai construit moi-même pour démontrer la faisabilité, l'intérêt, la rapidité, l'économie d'un tel système constructif. Donc, j'allais dire, c'est moi-même qui l'ai démontré. Quand j'ai fait ce premier bâtiment, j'ai montré celui-ci à des clients potentiels. Si le client est séduit, l'entreprise doit s'aligner sur ce que veut le client. Si le client dit « je veux un bâtiment en pierre », l'entreprise doit accepter cette donnée-là. Donc c'est grâce à ce premier bâtiment que j'ai construit moi-même que j'ai pu enchaîner tous les autres ensuite, les uns derrière les autres, pour convaincre. C'est pas facile, c'est pas toujours facile. Vous avez vu qu'il y a beaucoup de projets dans ma présentation qui n'ont pas été faits parce que effectivement, on a rencontré des difficultés, aussi bien avec un client qui était pas tout à fait convaincu, une entreprise qui nous démontrait que ça n'était pas possible. Un bâtiment comme celui que j'ai montré en dernier a mis des années avant de pouvoir sortir sous la pression, effectivement, d'un client qui, pour des questions juridiques, avait changé de nature entre le début du projet et la poursuite du projet. Ça nous a coûté extraordinairement cher. Si on utilise des systèmes de levage, des grues, pour porter la pierre, et que les capacités de ces grues sont importantes, on a tout intérêt à faire des pierres les plus grosses possibles. Alors, les plus grosses possibles en tenant compte aussi des gabarits de transport et aussi des capacités de la carrière à tailler des blocs de grande taille. Donc, tout part un petit peu de cette complexité entre la capacité de la carrière, le type de pierre, le transport, la distance à parcourir et ensuite, effectivement, le système de levage, les moyens de levage. On a, au cours de tous les projets qu'on a faits, utilisé des carrières qui faisaient des pierres de cette taille, etc. On a souvent redessiné 3 ou 4 fois les bâtiments en fonction des carrières qui pouvaient être disponibles pour construire nos bâtiments. Bien sûr, le module est extrêmement important et ce n'est pas par hasard que nos ancêtres, si je puis dire, faisaient des blocs qu'ils pouvaient transporter manuellement, donc à la main. Donc les tailles automatiquement sont beaucoup plus réduites.
Somebody's going to have to tell us to stop, but I think I've got a couple of more questions possibly.
I think maybe we have time for one more question. Sorry, I appeared then as if by magic.
One more
We're
question.
getting dangerously close to bedtime.
Okay, all right.
So
Well,
if you
probably
have one final question, that'll be great.
Well, I'll hopefully anybody who's still there and listening, I think Giles has demonstrated that you can build in stone, whether it's a very inexpensive, whether it's inexpensive social housing, single house, multi-story housing, or even 20-story multi-use buildings, offices and residential. I think that's extraordinary. I wasn't expecting to see some of that work actually physically on site in this presentation. So it's really reassuring for all of us to see that. Also demonstrating it can be done economically. So he hasn't given us the figures, but certainly in London with that research project we did with Jackson Coles, they demonstrated that even a 30-story office block built in the city center of London would be about 10% cheaper in all stone, and cheaper still if it had a mixture of stone and timber, meeting all regulations and obviously being extraordinarily low in its carbon footprint if it's all stone, and carbon negative if it's mixture of stone and timber. So this is all reassuring to see evidence from someone who's been working with it for a long time. I've got lots of questions. I don't really want to. I'm hoping that you'll be able to replace your use of concrete in basements and floor plates, because it's exactly what we're trying to challenge at the moment. We've come up with technical solutions, and one of the questions was going to be the types of stone you might use. Now, obviously, most of us are interested in aesthetics as well as the physical constraints, and so below ground, we're using things like basalt, igneous rocks. But again, it's a matter of persuading engineers and contractors. I don't know, which question do I choose? I don't really want to choose one last question. They're all equal value. I'm going to just leave you to conclude with your own thoughts on stone. I mean, it certainly doesn't dictate a style, which is another important thing for people to take away. It's just a material. It has lots of flexibility and in its structural and aesthetic outcomes. But I think, can I leave you to conclude with your experiences, something that we can all go away with?
Bien, alors c'est une question sans question.
I'm not sure what Pierre. I'm not sure what Pierre's translating, but I'll leave you to conclude.
Il y a énormément de questions qui n'ont pas été abordées. On les a simplement vues rapidement, comme celle de la question du thermique. Donc, comment on fait pour réaliser des bâtiments en pierre massive qui répondent aux réglementations thermiques actuelles. Alors, il y a une réponse qui est toute simple, c'est que les réglementations thermiques actuelles sont inadaptées. Il faut donc changer les réglementations thermiques. Il a été démontré, et Amin en a parlé, que la principale question aujourd'hui qui peut se poser pour réduire les émissions de CO2, enfin pour diminuer l'empreinte carbone des bâtiments, c'est de tenir compte de ce qu'on appelle l'énergie embarquée. Donc, énergie embodied, je crois en anglais. Il a été démontré, des chercheurs de l'université de Zurich, de l'école polytechnique fédérale de Zurich, ont démontré, par exemple, que si on prend les bâtiments qu'a réalisé Fernand Pouillon à Paris dans les années 1970, ces bâtiments, si on étudie l'énergie embarquée au départ, c'est-à-dire par la construction, donc je rappelle bien sûr que ces bâtiments sont entièrement en pierre massive, avec des simples vitrages et sans isolant, il est démontré que si on étudie la dépense énergétique de maintenance, en quelque sorte, donc pour chauffer, par exemple, ces bâtiments, sur 50 ans, eh bien, on n'arrive pas à avoir la même économie que si on a, qu'avec, alors je ne sais pas si j'exprime bien, je vais peut-être reprendre la démonstration différemment. La question, et qui renvoie bien sûr à la question de l'isolation thermique des bâtiments en pierre, c'est que les isolants thermiques qu'on utilise aujourd'hui, pour leur fabrication, dépensent une énergie qui est supérieure à l'économie qui est faite par l'isolation, par la réduction de la dépense énergétique. Donc, la question, c'est que si on continue, on va exactement faire l'inverse de ce qu'on est en train de poursuivre, c'est-à-dire la réduction des émissions de CO2. Les éléments d'isolation font que l'énergie dépensée est bien supérieure à l'énergie économisée. Donc, il y a une vraie question. Pour autant, on ne peut pas faire des bâtiments construits avec des matériaux extrêmement légers qui présentent une faible inertie. Il faut donc construire avec des bâtiments qui ont une forte inertie. D'ailleurs, c'est le cas des bâtiments en pierre, bien sûr, mais pas seulement. Les bâtiments en terre, on construit actuellement des bâtiments en terre en Afrique qui présentent une grande inertie thermique et qui sont une réponse au confort sans avoir recours à aucun isolant. Donc, il y a effectivement une grande question autour de ce problème, j'allais dire, de la thermique. Ensuite, faire des bâtiments entièrement en pierre, bien sûr que c'est possible. Nos ancêtres l'ont fait. Il y a notamment, par exemple, pour franchir des planchers, pour faire des dalles horizontales, un système très simple qui a été imaginé par un ingénieur français qui s'appelle Fraisier au XVIIe ou XVIIIe siècle, je crois, et qui est un système d'assemblage où les blocs de pierre, par leur taille, la façon dont ils sont taillés, se bloquent les uns les autres pour former un plancher horizontal. Il en existe encore des exemples en Espagne. Il y a dans certaines régions d'Espagne des planchers plats en pierre, entièrement en pierre, et sans rien du tout, sans acier, sans câble, sans que dalle. Pardon, que dalle n'est peut-être pas traductible. Bon, donc sans rien du tout, on arrive. J'en ai fait les démonstrations avec mes étudiants. J'étais professeur à l'école d'architecture et avec mes étudiants, j'ai souvent fait des expériences, dont celle-ci, qui est celle de franchir à l'horizontale avec des éléments de pierre de petite taille, relativement petite taille, disons, qui s'assemblent et qui permettent de franchir des planchers. Donc tout est possible en pierre. Et pour une simple raison, c'est que dans le passé, nos ancêtres n'avaient que ce matériau, pas que ce matériau, mais ce matériau principalement à disposition. Donc il fallait bien régler les problèmes qui étaient posés par ce matériau dans leur construction. Donc il suffit de regarder de partout. On a des voûtes horizontales, il y a des voûtes extrêmement intéressantes dans le sud de la France, dans l'hôtel de ville d'Arles, il y a des voûtes horizontales sans aucun élément d'acier. Tout le monde se pose la question, bien sûr, de savoir comment ça tient. Ben, ça tient tout simplement par le poids. Plus vous mettez du poids sur votre voûte, et plus elle va tenir, parce que plus vous aurez du poids, et plus vous augmentez la compression. Donc, plutôt que de mettre des câbles qui permettent effectivement d'augmenter la compression et la tenue des éléments, eh bien, augmentez plutôt la hauteur. Ça fera le poids qui compense effectivement la traction ou la compression qui est faite par des éléments d'acier. Alors, une dernière précision, c'est qu'avant d'être architecte, j'ai fait une formation d'ingénieur. Et ça me permet effectivement très souvent de contredire ce que peuvent dire mes confrères ingénieurs. je vais essayer de conclure sur cette idée, parce qu'on pourrait discuter pendant très longtemps, bien sûr, et il y a vraiment ces discussions sont passionnantes. À quand la prochaine discussion?
And on that note, I reappear to say a huge thank you. I think the beauty of this evening was thinking about not only about the versatility of the stone, but the power of great architecture. We've seen some amazing projects, and thank you all so much. Thank you, Gilles, for a great presentation. Thank you, Amin. I will do a massive shout out thank you to Polycor as well, our sponsors. Thank you to Brian Thorburn then as well for the brilliant translation. Thank you to our 3 curators. Thank you so much. Thank you as well to Frederick and Christophe for sharing your work with us. It's been a real pleasure to learn more. There's lots of questions we were asked on a Q&A portal on Zoom. We'll try and get some of those answered. There's lots of stuff on the Building Centre website about stone, things that we've discovered on the way, things that we've learned from our 3 curators and all the participants in the show. So there's lots of stuff there on the Building Centre. Thanks to Valerie as well for being there, supporting us through this. Thank you to all the participants who've stayed with us this evening. And it really is time to say a massive merci to all of you, and bon rêve, bonne nuit.